All right, young scholars, good morning. So let's jump into activity for processing 2.21. This is unit 2, lesson 21, which will get you ready for cool down 2.21. You will see our first example has us trying to solve 3 over 6 minus x equals to 15 over 6 plus x. Now on the cool down, you will see that it's going to say that x has restrictions placed on it. In this case, x cannot equal 6 and x cannot equal -6. Quick explanation behind that is, let's suppose that you do plug in 6, for example, into the equation right here. So let's try this one and put it in there. Well, then that means you're going to end up with 6 minus 6 on the denominator section of the problem, which then, if you know 6 minus 6 reduces to 0, this is going to bring up problems, because if you think to yourself, what is 3 divided by 0? It should bring up some memories that you cannot divide by 0. And if you do, you get something called undefined. We won't stress this too much in the work for today's cool down problems. However, I just want you to be aware that when you do see those restrictions in the question itself, it's referring to the denominator, us avoiding it reducing down to 0 at any cost possible. Okay, so you will see 2 restrictions there. Other than that, we don't really need to stress that. Let's get into the steps, the calculations, which is where I would feel we should be more concerned and our energy should be directed towards finding the value of x. So I know my students love the cross multiplication, the butterfly method. So I know this is going to be good news for you folks. You're like, oh, I've seen this before. Indeed. So what we're going to do first for our first step is multiply the denominator of the right fraction with the numerator of the left fraction, or you can just simply look at the circles I have drawn. Then what we're going to do is we're going to go ahead and create our next line. We have 3 times 6 plus x. So this is called cross multiplication. I'm going to put it in quotations. You know, this is how people know it. It's called cross multiplication. So we're going to multiply across here. We're going to do the same with the other 2 values, specifically the denominator of the left fraction and the numerator of the right fraction. So this is the denominator, and we're going to multiply it with the numerator, and we're going to write that result down here. So now we got 15 times 6 minus x. All right, cool. We got our next step down. Next, we're going to use a distributive property. The next step that I'm going to do is not mandatory. It can be done mentally. However, I want to show my work so students know. Because if I do this, 18 plus 3x equals 90 minus 15x. Some of you might be looking at them and be like, oh, okay, I know what you did. You did distributive property, which is fine. But it actually I would like to actually show the step there. So this step that I'm going to write in orange is how we got from this step to this step. It is not mandatory step. However, there's no restriction on how many steps you can use to solve a math problem. So what we did is we used a distributive property. We multiplied 3 times 6, which I'm writing down right here, 3 times 6. We also multiplied 3 times x. And 3 times 6 gives us 18. 3 times x gives us 3x. Similar situation over here. We're going to distribute 15 times 6, that's 90. And then 15 times negative x gives us negative 15x. That's how we got this step right here. All right, this next step here, there's a couple of different ways to do this. So what I'm going to do here is just one option in the logic branch as to how to get to the solution. So what I'm going to do here, I'm going to show you a couple of different ways you could do this, just for the sake of variety and to give you options. But then I'm going to erase everything here and then just like show you how I'm going to do it. Okay. So one thing you could do here, you could subtract 18 and 3x from both sides. could do that. Sorry, there should be no X there. Okay, you could do that. So you're noticing that I'm doing two things at once with that particular step there. We could subtract 90 and add 15x, which is the inverse of the pink values above. And if I do that to the right, I have to do it to the left. Right. So you can actually do two steps at once. But what I'm going to do, I'm actually going to do one step at a time. But that is a bit more advanced way of doing it. So what I'm actually going to do is I'm going to subtract 8 from both sides. Or 18, I'm sorry. And I'm also going to add 15x. So which one do I want to do first is up to me. So let me show you. This is one way you could subtract 18 from both sides first. And then yada, 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 you get some more steps. And then you can do the addition of 15x to both sides. That's one way. That's not the way I'm going to do it. I'm just showing you like that is a possibility. Okay. So the way I'm going to do it is like this. I'm going to add 15x to both sides. Which then, I was conflicted before this. I was like, do I want to draw the line? And the answer is kind of, it gets kind of messy when I start drawing the line and whatever. So now we're going to drop down this 18. Nothing was conducted on it. And then 3x plus 15x, that's going to give us 18x. On the right side, nothing was done with the 90. And then you will notice that negative 15x and plus 15x give us 0x because they cancel out. So we're done with that. Now what I'm going to do next is I'm going to subtract 18 from both sides because ultimately what I want to do, or let me explain what I'm doing. I'm getting the x's together. So you notice there's no x values over here. They're right here. So now I got the 3x and the 15x. I put them together on the left side. I want to isolate 18x by itself. So what I'm going to do is I'm going to get rid of the constant 18 and do exactly that. Here comes this other line that I had to contemplate last night. The 90 minus 18 gives me 72. And now I'm going to go ahead and just point out that the 18x is isolated. So I have the x values on one side and I have the constant value on the other side. This is exactly what I want. So from here, this pink step, no matter what you do, ladies and gentlemen, you should arrive to a solution like this. Okay. There might be a situation where you actually arrive like, in some cases, you arrive to something like this. Let me just do this kind of on the side here. You may arrive to this. Okay, let me talk about this situation real quick. So if you do arrive to this, negative 18x equals negative 72. I'm not saying you will, but just in case you do, or in any other problem, you arrive where the left side and the right side are both negative, you actually need to divide both sides by negative 1. Which then gives us 18x equals 72. There. Okay, just in case you do run into that situation, okay? You do want to divide both sides by negative 1. I'm going to go ahead and just kind of highlight this. I believe there's a question on the cool down multiple choice portion that actually asks you, well, what if both sides are negative? What should you do? You should divide both sides by negative 1. And I'll write that down here. Divide by negative 1 on both sides. Okay, let's wrap this thing up here. This is where the warm-up wants you to stop, right here. But I'm going to take it all the way down, right? So it's going to say, what are the steps necessary to get to the solution 18x equals 72? That's great. That's dandy, but that's not enough for me. I'm actually going to take it all the way through. Okay. Then 72 divided by 18. I'm actually going to just reduce it here. Now you notice here I get 8 over 2 because I divided 72 by 9, which is 8. 18 by 9, which is 2. Am I done? No, I need to reduce all the way. All the way. This is reduced, but I need to reduce all the way. So I notice that I can just simply divide 8 divided by 2, which is 4. All right. And this is pretty much the step-by-step process and guide as to how to arrive to the solution of x. Now, if you really wanted to check if your solution of x, and I'm not going to do it in this video because I've done it before, and I'm more than glad to actually do it in class if you want, is to, you could take the value of x and plug it into the equation and see if it works, right? So on the left, you have 3 over 6 minus 4, which will give you 3 over 2. And then on the right side, you'll have 15. And then 6 plus 4, that's 10, right? So 3 over 2, is that equal to 15 over 10? Yes, because you will notice that 15 over 10 and 3 over 2 are just different multiples of each other. So 3 over 2, you would say, is a reduced version of 15 over 10. So checking your work, as always, is a great tool to see whether or not your work is correct. All right, ladies and gents, thank you for example 1 and taking the time to do this. So if you want, you can always replay the video. Go up here, copy this question down in your notebook, because that's how you should be watching the videos, right? And then see if you can do the steps all by yourself, right? So copy down the problem, hit pause, see if you can go through the steps all by yourself, hit play, and if you want, you can even kind of fast forward if you wish, and then see if you get to the solution over here, which I should have circled. Shame on me, but there it is. Okay. All right, without further ado, good luck. Let's see how we do.